Meet Mario, a cart driver. When he's driving, Mario pays attention to three things: the fuel gauge, the oil gauge, and the speedometer, so he can either ensure everything is going smoothly or identify an issue. In case of a problem, red indicators alert him, prompting him to take action, like refueling or adding oil. But to truly optimize his overall performance, he needs to find connections between these metrics and less obvious factors. For example, he needs to measure the impact of tire pressure on his speed and fuel consumption depending on the terrain: snow, mountains, rainbow road, etc. And this is the core principle of observability, which goes beyond data collection to also analyze the data in context. The goal of observability is to understand a system's internal states by examining its outputs. To achieve this, three key types of information need to be collected. First, metrics, or numeric data representations that allow real-time system performance monitoring, like CPU usage, memory usage, error rates, throughput, etc. Then, logs, which are records of events, actions, and errors within the system. They help identify the root cause of failures and contain detailed, customizable information. Finally, traces, to track the journey of a request through various parts of the system, helping to understand interactions between different components. With metrics, you get simple data without context. Logs provide lots of context, but are limited to what developers have predefined. Traces, unlike the other two, aren't predefined. They capture the actual execution context, making them the main thread for data analysis. But simply collecting this information isn't enough. Data collection is just the starting point, because observability is about knowing what to do with these three types of data. Indeed, a system is considered observable when it is possible to gather relevant information about its state and monitor its internal behavior, quickly identify potential problems, and take proactive measures to improve overall performance, and gain a deep understanding of the system's overall behavior. If we were to summarize the philosophy of observability, it would be the ability to get answers without having to predefine all the information to monitor. Let's see all this with a more concrete example. Imagine managing an e-commerce website. It is essential to ensure that users can browse products, add items to their cart, and complete purchases. Observability will monitor server performance, track errors in transactions, and trace requests from users navigating the website. By correlating data, issues such as a slow checkout process caused by a specific service can be quickly identified and fixed. Observability also detects anomalies before they escalate into major issues. For example, if a gradual increase in error rates is noticed, addressing the root cause can prevent it from affecting the entire system. And when failures occur, examining logs, metrics, and traces helps understand what went wrong and implement measures to prevent similar issues in the future. Observability becomes crucial with modern architectures. Indeed, with microservices architectures, applications are distributed across many services, each autonomous, yet interconnected. Each service is developed by different teams, making it increasingly difficult for organizations to have a comprehensive view of their application as a whole. Observability helps understand how these services interact. Beyond identifying malfunctions and their origins, observability aims to help organizations regain control of their information systems and make informed decisions about architecture. Finally, let's distinguish between monitoring and observability. Monitoring tracks the performance of an element of the information system: operating system, database, network, application, etc. However, the limitation is that often each element is monitored in silos without a consolidated view. Thus, even comprehensive monitoring is not the same as observability. And monitoring everything is not observability. With observability, you should be able to aggregate all this data, including monitoring data, to extract useful information using data analysis, correlation, and visualization techniques to better understand how the different elements of the system interact. And finally, Here are examples of popular observability tools: Prometheus, Elasticsearch, Logstash, Kibana, commonly known as ELK, Dynatrace, Splunk, and Datadog. Thank you for watching my video. If you enjoyed it and it helped you understand the topic better, please subscribe to support my channel. See you soon.